Okay, I think I'm gonna start. Good morning, everyone. I think DSLs in Groovy are one of the key aspects of the language. One of the first things that we promote when we are showing someone the language, Groovy, it's how concise and how easily we can program with very small pieces of code, and this because the DSLs. I don't know if you know this guy. This is Eric Evans. Almost all the things that I've seen written about DSL starts with these kind of things, domain-driven design, how you should put the rules of your domain inside your system, But I'm not here to talk about. I'm not here to talk about why you should use DSLs, but I want to talk about how you can achieve an implementation of a DSL. I mean, I want to show you how the sausages, well, you can see here very well, but I want to show how the sausages are done, okay? Well, first, okay. This is a tweet from the Greach conf telling you that I'm coming from Narnia, and it's true. This is a very magical place, Narnia, very fine. I'm from here, around here. It's fine. And I'm going to show you some magic in this presentation. But I want to show you what is behind that magic. Okay, but first things first. What is what we understand for a domain-specific language? I mean, this is like the formal definition. Well, it's a programming language that, through appropriate notation and abstraction, shows expressive to a particular problem domain. But this is strange, no? You should be strange about this definition, because in Groovy we have already a programming language. So how is that even possible? And a problem domain, it's not always what we use as a domain-specific language for. So it's not for a domain, it's not a language. Well, the thing specific, it's true, okay? So I like this definition a little more, at least for Groovy. What we understand in Groovy for a DSL is this. It's an expressive, and this thing is the key part, the expressive abstraction or notation for a particular problem. Okay, this is my definition. But I think I'll show you with real code. I mean, how we use in our daily lives this kind of DSLs. For example, for configuration, this is Grails code. We are defining all the appenders for our logger system. This could be a login DSL if you want. This is another classical example. I mean, the constraints in a GORM class. We use it almost, I don't know how many of you are Grails developers, but if you are using Grails, you use this almost every day. So this is also a DSL. We can use it for an expressive API. What I said before, this is a great example of a DSL in Groovy. This is the criteria DSL of GORM. It's very nice, no? You are almost programming in SQL with this, no? Well, what I meant for notation is this example. I don't know how many of you are using a Spock, but there is a very, very nice trick. Well, a very, very nice notation for data-driven testing. Is this kind of Hasty table almost, no? Where you express the two values A and B and expect a result C, and then this is automatically generated, no? This is what I meant for a specific notation. And of course, you can also make the user give you input. For example, in Gradle, there is a lot of DSLs, and they are so natural that even people that doesn't know Groovy can use them easily. I mean, there are a lot of people using Android that haven't used Groovy ever, and they are using this kind of DSLs. No, that's the key concept. So yeah, how cool is that? It's pretty cool. But the funny thing is that we think that only the Grails team can do this kind of DSLs. I don't think so. We can do it, okay? It's not that hard. So here in my presentation, I will show you five techniques for this kind of DSLs. But first, I need to review some things that will help us to improve our DSLs. This is like very small things that maybe you know already, but I think they are very, very important to make an expressive DSL. For example, optional parentheses. I don't know if you know that you it's optional to put parentheses in expressions. No? Here, I don't know if you can show at the back very well, but well, this is the one that most of you know, I think. The parentheses in Groovy are optional, but the getters and setters, no? There is a shortcut for the getters and setters. You only have to put set a property, and then you can use only the name of the variable equals the value. All right? This is quite easy. The same for the getters. All right? I'm going to go quite fast here. Operator overloading. This is very important because for some expressive notations, this is one of the things that they use the most. All these operators, well, I'll put the slides afterwards so you can check them afterwards, but all these operators can be changed for a specific class. Keyword arguments. This is, maybe you don't know this one. If you put a map here at the beginning of the declaring method, afterwards you can call the method this way. You don't have to put square brackets here. You can call directly. Yeah, and this, you know, it's like a variable arguments. And the closure. If your method had a closure at the end, then this kind of notation you could call outside, like it's not part of the arguments. It's like the body of the closure, all right? Okay, Uncomment Chaining. I don't know if you know that in Grails, not only parentheses are optional, but in some cases, dots are also optional. When you have this kind of calling, it's a method call with an argument and then the result with dot, another call arguments, you know, you can express it this way without even parentheses, nor dots. And this will be very important afterwards. Okay, so let's talk about the thing. First, closure DSLs. This is the typical example, starting with the DSLs in Groovy. You want to send an email, and instead of put a very big map at the argument, you call with this kind of DSL, no? This is nothing strange here, no? These two are method invocations, but where are these methods? Because in Groovy, unlike other languages like Python, there are no functions. All the methods are called into an object. I mean, from is not a function in the ether. From is a method for a concrete instance of an object. And there are three objects that could be called in this case: the this, owner, and delegate. Most of the times they are the same. All right? The only difference is this is always the thing that we expect is the owner of, well, this is complicated because they mix these terms, so but this is what you would expect. I mean, if you have a closure and you are calling a method, this is the owner. Sorry. I don't want to use owner because owner means other thing, but owner is the one who owns that code, so it's quite hard, okay? But all right, this is what you expect, okay? Owner only changes when there is a nest closure. I mean, if you have only one closure, this and owner are the same. But if there is a nested closure inside, owner is this of the parent. Well, it's a mess, okay? Don't worry. The thing that it's important for us is the delegate, because the delegate is the one that can be changed. And you can tell Groovy that this object overrides the other two. So this could be the class that implements all the methods in the DSL before, okay? This could be the implementation for the send. The key point here is this method call, rehydrate. This method returns another closure that changes the delegate, in our case. It's the thing that is most important for us here. Afterwards, you tell that closure that only the delegate is the important thing. And at the end, you just call that closure, right? And you then retrieve all the data that it's now in the delegate. So with this, you have your first DSL in Groovy. So just like a summary of what I just told is all the closure, the body methods, will be called to a delegate, okay? So you have to build your DSL around that delegate. Groovy builders. What's the problem here? I don't know, it's quite small, I don't know, okay. This is very similar to the example that we just saw, but there are a lot of nested closures, okay? It's author that has books, that have a concrete book, that in this case is Game of Thrones, so there are houses, like a start that has a motto. If you want to do this with a delegate, it could be a pain, all right? So this is a hell. Groovy has a very nice interface, but for this kind of DSLs, it's called, it's the class is builder support. The builder just define a tree-like structure. So in our previous example, you could think of this as nodes that are related. I mean, books has a father node with children down, all right? So then, when you implement this kind of interface, the only thing that you have to tell Groovy is how you should create the nodes and how they are related, all right? Just those two things. And then, with those two things, create the nodes and then define that structure, then profit. Automatically, you can access your constructed object through this kind. I mean, you create book self, inside has items, and the first item has more items, This way you can easily access the data contained in this DSL. Okay, so these are two of the examples I wanted to show you. The third one is open classes. I think this is not so typical in Groovy as it's in Ruby, but we can do this as well. I mean, you can extend predefined classes like integer and add methods to this class. I mean, here, for example, I'm adding to the integer a method random times. I don't know if you know the method times. For example, in Groovy, you put temp.times. You have an iterator that repeats itself 10 times. So random times is the same thing, but a number of random times. The delegate here is the proper integer. I mean, if you put 10.times, the delegate would be 10, the number 10. And, well, this is what it looks like. Just 10 dot random times and println. So then a random number of printlns would appear. But, well, why I'm telling you this kind of method? Because allow us to create very fine DSLs like this, just almost like natural language. Buy 10 bottles of milk. Order 10 books of whatever. And it's quite easy. You only have to extend the integer 10 with get bottles and then return your object. Of course, this object quantity has to have a method of. Okay, I hope you follow me until this part because they are coming curves. Okay, when I told you that we could do it, I mean literally. I mean, this kind of notation is like the most strange thing that you could see for a DSL. I mean, what the hell is this? It's like Hasty art. What? But for these things, the DSLs, the ASTs are quite useful because what an AST does is using the same syntax as your language, you can convert this to another totally different code. You have to respect the syntax. It's the only rule for ASTs. Apart from that, you can do almost anything. Why disrespect the syntax? That's the first question. For this STR to be compatible, it has to be the Groovy has to be compliant with the Groovy syntax. Here, these are bitewise OR operations, and this is our logical OR. So you can read it as A, I don't know what is A, but it's something, or B, and these two together, or C. But that doesn't mean anything. It's just the syntax is correct. But we can change the semantic, the meaning of this table, no? Here, for demo purposes, I added a local AST to this table, all right? And then what I expected it to do. So if you have a method getTable, afterwards when you call getTable, you will have that value 1 is 1, 2, 2, 1, 2, 2, and value 2 will be 2, 1, 2, all right? That's all it does. So it's this kind of conversion, all right? It's nothing more. You have to change the body of the method to a map return. Easy, no? All right, here I'm going to show you one. All right, this is the Groovy Console, okay? And this for AST programming is superb. It's the best thing. I have here the two methods that I just showed you. So here I have a problem that it's not mirrored. So Groovy Console you can check the AST browser. So I just opened the AST browser to get the AST of these two methods. Okay? And here you can check for these two methods what are the AST they have. All right? And you can even check the classes. I mean, the first expression statement is the class. You know the class and the structure of your AST. So what do you need more? You have you have the source and the target of your AST. So now it's just a matter of convert from one to another. And believe me, it's not that hard. I will put the code for this DSL online so you can check, but what I was telling you is just don't be afraid of the ASTs. All right? This tool helps a lot. You can do almost anything with them. Yeah, this is what it looks like, the finished transformation. I retrieve all the statements in the original table-like structure, and then from that block of code, I extract the header, the header of the table, the value 1, value 2, value 3, and then the body. This method will only retrieve the map with the values. That's the only thing that interests us. And then from that from that data, I create a new AST and just delete the old one and put the new one. That's it. Okay, summary of this part. Try your DSL for the AST in the Groovy Console. Check the AST of the source and the target, and think how you convert from one to another. That's it. And no magic involved. Okay. So far, so good. I'm going quite quickly, as always. Okay, scripting. If you have used Gradle, you have seen this kind of document. No, this is like the easiest possible Gradle build. No, well, it's not easy, but I mean, but these are just method calls, like the ones that we saw in the first technique. These are closures that will delegate afterwards to a handler, no, to a delegate. But where are if you put this in a .gradle file, where are those method calls? No, because there is no way to access those data, no? Well, there is. You can declare a binding. A binding is just a map which keys are the method, this kind of calls, repositories. This is the key of our binding. And the body are closures that we do whatever they wanted to do. Then to evaluate your build Gradle, you only have to call this method, evaluate. But if you don't want to use a map, a generic map, you can also use a class, an instance. and store the state inside that instance. This is too small maybe. The important thing here, okay, this is just configuration. You have to tell Groovy that the script you will call is a script that could be set a delegate. I mean, Groovy by default use the binding that I just showed you, but you can also tell Groovy that you will going to put a delegate object, and this is the the key method, set delegate. Well, if you do that, then when you run the script, all the methods inside that script will call the delegate, right? Okay, but you can do a lot more things into your script. For example, you can put imports, default imports. In this example, for example, I just import all the constants in the class calendar into my script. So when I'm working with my script, I can just access days of the week, you know, directly, and my script doesn't have to have more imports there. But you can also apply the techniques that we just saw in the previous point. You can tell the script that you want a Hasty transformation to be applied inside that script. In this case, I'm using @log. I don't know if any of you were in the presentation by Ivan yesterday, but it's one of the ones that uses the @log. The only thing that does is creates a log instance inside your method call, so you can call your log4j or sl4j or whatever. Okay, you can do more. You can do a lot of things with this kind of configuration. You can also sanitize the user input. I mean, you don't trust the user, so you don't want him to maybe you don't want him to define new methods inside the script your application is accepting. No, this secure Hasty customizer is very powerful. You can whitelist methods, whitelist, blacklist properties, almost do whatever you want. That's it. Those are the 5 techniques I wanted to show you. I have a lot of time as usual. If you want, I can show you more of the code of the AST, but I don't know. Yeah. All right. Okay. This is like the bonus track, all right? This is the first part. I mean, what I just told you is once you browse the AST, you can take all those AST generated code that you just saw in the Groovy Console and throw it here as it is. This is just the code representation of the thing I showed you before. All the map expression with nested map, you know, that's it. The second step is just to all that mess that was hard-coded, I generalize it so you can do this kind of conversion. From a map, it will generate the AST that correspond to that map. All right? Okay, and the only thing that is left is process the headers and the body and get a map that with this data. What I did is the the AST, like its name, well, it's a tree, no? It's abstract syntax tree. So you can try algorithms like the for tree traversy. I mean, this is a pre-order of binary methods, no? I showed you that value 1 uses value 1 has a bitwise OR with value 2. That's a binary operation. A binary operation means that has two values. And then you process that tree, retrieve the map, and with the method that I just saw in here, the target is to achieve this map. So you traverse your syntax tree to achieve this map. And then just has to replace one piece of block with the other. That's it. So that's it. Any questions?
Some of your code is fixed to binary operators.
Mm-hmm.
That means that if you want a different expression to evaluate, you need to change your specific code to fix that length of parameters or something like this.
Yeah, it depends on what you want to create. I mean, for this concrete example, I knew that it is going to be a binary operation. But if you want to do other kind of AST, depends on the concrete methods. Of course, this is not a complete implementation. There is no error handling or whatever. I mean, I hope that the thing that they send me, it's correct. Otherwise, it will fail very badly, I think. The thing with ASTs is that they are inside compilation time. So if it fails, it will not compile even. So that's a problem. Any more questions?
Have you ever used this in your daily work? Can you provide some example?
Yeah, well, for some of the plugins that we did, there is some Hasty transformations. And also for some of the plugins, it's okay. The thing with DSL is that they provide an API to another developer, no? So it's very, very nice to put it in plugins, for example, because they are used, we hope they are used for other developers. For example, the plugin that we did for Grails admin uses a lot of some of these techniques. And the PostgreSQL extensions also use some of the AST, no?
The plugin uses an AST to remove the actual type that you write in your domain class and put another type under the hood that we create to handle this map before our pull request was affected into Greach store, because there was a bug with when you have a domain class with a map and you want to with a map type and you want to map this property to another Hibernate user type. So we create a own map type and under the hood remove it and change with this transformation.
And for the one of open classes, I have one plugin that it's the time travel that does this kind of things. The thing with time travel was to do the, like, you could when you have a GORM timestamp, no, that date created, but maybe in your test you want to change that date created, but it's not an easy thing to do. So what I did was a DSL to go backwards and forwards in time. So you could go like 10 days forwards, 10 days backwards, no, that kind of things. And yeah, I hope I answered your question. Any more questions? No? Well, so I don't know. I hope it wasn't too difficult, really. I put this like an intermediate talk, I think, Maybe it's a bit more complicated than that, but I hope you enjoy it. So thanks.